Welcome to Max online class. Exercise 9.3. First sum. Find the left and right limits of f of x is equal to x square minus 4 divided by x square plus 4x plus 4 into x plus 3 at x is equal to minus 2. F of x is equal to x square minus 4 divided by x square plus 4x plus 4 into x plus 3 at x is equal to minus 2. Now you have to apply the limit in both the sides. That is, limit extends to minus 2. So limit extends to minus 2, x square minus 4 divided by x square plus 4x plus 4 into x plus 3. Now you consider the number line. In the number line, you have in the left hand side you have minus 2 minus, and in the right hand side you have minus 2 plus. Now you consider the left hand side limit, that is minus 2 minus. Limit extends to minus 2 minus, x square minus 4 can be written as x plus 2 into x minus 2 divided by x square plus 4x plus 4 can be written as x plus 2 whole square into x plus 3. X plus 2 cancels, remaining you have limit extends to minus 2 minus x minus 2 divided by x plus 2 into x plus 3, which is equal to infinity. Now you have to substitute the place of x. The place of x you have to substitute minus 2. Then you will get minus 2 minus 2 minus 4. Numerator you have minus 4, and in the denominator if you substitute minus 2 you will get 0. So any number divided by 0 you will get infinity. Next, if you want to find either this one will be a plus infinity or minus infinity, so for that you have to apply x is equal to minus 2.1. Minus 2.1. If you substitute x is equal to minus 2.1, then you will get plus infinity. So f of minus 2 tends to infinity as x tends to minus 2 minus. Then limit x tends to minus 2, x square minus 4 divided by x square plus 4x plus 4 into x plus 3 is equal to limit x tends to minus 2 plus. Now you consider the right hand side. Right limit, right hand side minus 2 plus. X square minus 4 can be written as x plus 2 into x minus 2 divided by x square plus 4x can be written as x plus 2 whole square into x plus 3. X plus 2 cancel, so remaining you have limit extends to minus 2 plus x minus 2 divided by x plus 2 into x plus 3. Then you will get infinity. Similarly here also you want to find either this one will be a plus infinity or minus infinity. Now you have to substitute in the place of x minus 1.9. If you substitute minus 1.9 you will get negative infinity. So f of minus 2 plus gives minus infinity as x tends to minus 2 plus. Subdivision B, f of x is equal to tan x as x is equal to pi by 2. Then limit x tends to pi by 2 minus. Now, similarly here also you consider the number line. In the number line, the left hand side you have pi by 2 minus, and in the right hand side you have pi by 2 plus. So consider the left limit pi by 2 minus tan x is equal to, now substitute x is equal to pi by 2, then you have tan pi by 2. Tan pi by 2 is infinity. Tan pi by 2, tan 90. Tan pi by 2 means tan 90, that is pi by 2 minus means less than 90 degree. So less than 90 degree means all the angles are positive, so that it lies in the first quadrant, so plus infinity. F of pi by 2 pi by 2 tends to infinity as x tends to pi by 2 minus. Limit x tends to pi by 2 plus tan x is equal to tan pi by 2, which is equal to minus infinity. Pi by 2 plus means more than 90 degree. So that is it lies in the second quadrant, so you will get minus infinity. F of pi by 2 tends to minus infinity as x tends to pi by 2 plus. Second sum. Limit x tends to 3, x square minus 9 divided by x square into x square minus 6x plus 9. F of x is equal to limit x tends to 3, x square minus 9 divided by x square into x square minus 6x plus 9. Now you consider the number line. In number line you consider the number 3. In number 3, the left hand side you have 3 minus, and in the right hand side you have 3 plus. Now you consider the left hand side limit, that is 3 minus. The place of x tends to 3 you have to write x tends to 3 minus. x square minus 9 can be written as x plus 3 into x minus 3 divided by x square. X square minus 6x plus 9 can be written as x minus 3 whole square. X minus 3 cancel. So you have a limit extends to 3 minus x plus 3 divided by x square into x minus 3. Now substitute x is equal to 3. So you have 3 plus 3 6 divided by 3 square 9. Here 3 minus 3 is 0. Any number divided by 0 is infinity. Next we want to find the symbol. Either it will be minus or plus. So for that you have to substitute. Here the limit is x tends to 3 minus. Now you take down the number x is equal to 2.9. If you substitute x is equal to 2.9, then you will get minus infinity. So f of 3 tends to minus infinity as x tends to 3 minus. Then now you consider the right limit, that is 3 plus. Limit x tends to 3 plus x plus 3 divided by x square into x minus 3. Again you have to substitute x is equal to 3, then you will get infinity. Similarly here also we want to find the symbol. So for that you have to apply x is equal to 3.1. So if you apply 3.1, x is equal to 3.1, then you will get positive sign, plus infinity. So f of 3 tends to infinity as x tends to 3 plus. Third sum, limit x tends to infinity 3 by x minus 2 minus 2x plus 11 divided by x square plus x minus 6, which is equal to limit x tends to infinity. Now you take down the LCM. The denominators are not same. The denominators are not same, so you have to take down the LCM. The LCM is x square plus x minus 6 into x minus 2. Then cross multiply. So you have 3 into x square plus x minus 6 minus 2x plus 11 into x minus 2. Then multiply the 3 inside the bracket. So you have limit x tends to infinity 3x square plus 3x minus 18. Then if you multiply these two terms, then you will get 2x minus 2x square minus 7x plus 22 divided by, you keep the denominator as it is, x square plus x minus 6 into x minus 2. Limit x tends to infinity 3x square minus 2x square x square 3x minus 7x minus 4x minus 18 plus 22 plus 4 divided by, you keep the denominator as it is. Now limit x tends to infinity. In the numerator x square is common, so you take outside. Before that you find out the largest power, find out the largest degree. After finding the largest degree, then you take out, then you have here the largest degree is x square 2. The largest degree is 2, that is x square. You take out x square, so you have x square into 1 minus 4 by x plus 4 by x square divided by, similarly here the largest power is 2, so you take out x square. So you have 1 plus 1 by x minus 6 by x square into x minus 2. X square cancel. Now apply x is equal to infinity. So you have 1 minus 1 by infinity. 1 by infinity is 0. Here also 1 by infinity is 0. 1. So 1. Similarly denominator also 1 plus 1 by infinity is 0. Here also you have to apply infinity. So infinity into 1, infinity. So 1 by infinity is 0. Fourth sum, limit x tends to infinity x cube plus x divided by x power 4 minus 3x square plus 1. Limit x tends to infinity x cube plus x divided by x power 4 minus 3x square plus 1. Consider the numerator. In the numerator find out the highest power. Highest power 3. So you take down, you take out x power 3. Then you have x cube into 1 plus 1 by x square divided by, similarly find out the highest power in the denominator. Here the highest power is x power 4, so you take outside. So you have x power 4 into 1 minus 3 by x square plus 1 by x power 4. Now cancel the numerator and denominator by x power 3. So you have limit x tends to infinity 1 by x into 1 plus 1 by x square divided by 1 minus 3 by x square plus 1 by x power 4. Now you apply the limit. So you have 1 by infinity. 1 by infinity is 0. Seventh sum, limit x tends to infinity x cube divided by 2x square minus 1 minus x square divided by 2x plus 1, which is equal to limit x tends to infinity. Here the denominators are not same, so find out the LCM. The LCM is 2x square minus 1 into 2x plus 1, then cross multiply, so you have x cube into 2x plus 1 minus x square into 2x square minus 1. Limit x tends to infinity, multiply x cube inside the bracket, so you have 2x power 4 plus x cube. Similarly here also you multiply minus x square inside the bracket, so you have minus 2x power 4, minus into minus plus 1 into x square divided by, similarly multiply the denominator also, so you have 2 into 2 4x cube minus 2x plus 2x square minus 1. Limit x tends to infinity, plus 2x power 4 minus 2x power 4 cancel, so you have x cube plus x square divided by 4x cube plus 2x square minus 2x minus 1. Now limit x tends to infinity. Now in the numerator find out the highest power. The highest power is x cube, so take outside, so you have x cube into 1 plus 1 by x divided by, similarly in the denominator find out the largest power. Here the largest power is x cube, so take outside, so you have x cube into 4 plus 2 by x minus 2 by x square minus 1 by x cube. X cube cancel, and then you apply the limit, so you have 1 by 4. Eighth sum. Show that limit n tends to infinity 1 plus 2 plus 3 plus etc. up to n divided by 3n square plus 7n plus 2 is equal to 1 by 6. Consider the left hand side, that is limit n tends to infinity 1 plus 2 plus 3 plus etc. up to n divided by 3n square plus 7n plus 2 is equal to limit n tends to infinity. Numerator is in the form of sum of the first n natural numbers, so its formula is n into n plus 1 by 2 divided by, you keep the denominator as it is. Limit n tends to infinity. In the numerator here n you take outside, then you will get n square into 1 plus 1 by n divided by 2. The denominator, the highest power is n square, so take outside, so you have 2n square into 3 plus 7 by n plus 2 by n square. Then you have n square cancel, then you apply the limit, so you have 1 by infinity 0. The numerator you have 1 divided by, and the denominator 2 into 3 plus 1 by infinity 0. Other terms are 0, only the remaining terms 2 into 3 6, 1 by 6. Subdivision 2. Limit n tends to infinity 1 square plus 2 square plus 3 square plus etc. up to 3n square, 3n whole square divided by 1 plus 2 plus 3 plus etc. up to 5n into 2n plus 3 is equal to 9 by 25. Consider the left hand side, limit n tends to infinity 1 square plus 2 square plus 3 square plus etc. up to 3n whole square divided by 1 plus 2 plus 3 plus etc. up to 5n into 2n plus 3 is equal to limit n tends to infinity. Numerator is in the form of sum of the squares of the first n natural numbers, so its a formula is n into n plus 1 into 2n plus 1 divided by 6. So here n is 3n into 3n plus 1 into 6n plus 1 divided by 6 divided by, the denominator is in the form of sum of the first n natural numbers, so its formula is n into n plus 1 by 2. So here n is 5n, so 5n into 5n plus 1 by 2, and 2n plus 3. Now n cancel. Before that, here n you take outside, here also you take outside, so remaining you have n into n cube into, cancel the numerator and denominator by 3 tables, so you have 2 cancel, so you have 3 into 1 plus 1 by n into 6 plus 1 by n divided by, similarly here also you take outside, here also n you take outside, so totally you have n cube into 5 plus 1 by n into 2 plus 3 by n. N cube cancel. Now apply the limit, so you have 3 into 6 divided by 5 into 5 into 2. Other terms are 0. Then if you multiply, you will get 80 divided by 50. Now cancel the numerator and denominator by 2 tables, so you have 9 by 25. Subdivision 3. Limit n tends to infinity 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 plus etc. up to 1 by n into n plus 1 is equal to 1. Consider the left hand side. Limit n tends to infinity 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 plus etc. up to 1 by n into n plus 1, which is equal to limit n tends to infinity 1 into 1 by 2 can be written as 1 minus 1 by 2. So if you take down the LCM, you will get 2 in the numerator, 2 minus 1. 2 minus 1 is 1 by 2. So 1 by 1 by 2, 1 by 2, 1 by 2 can be written as 1 by 1 into 2 plus 1 by 2 into 3 can be written as 1 by 2 minus 1 by 3. Similarly, 1 by 3 into 4 can be written as 1 by 3 minus 1 by 4 plus etc. 1 by n into n plus 1 can be written as 1 by n minus 1 by n plus 1. Here plus 1 by 2 minus 1 by 2 cancel, minus 1 by 3 plus 1 by 3 cancel. Similarly, minus 1 by n plus 1 by n cancel. So remaining you have the first and the last term. So that is limit n tends to infinity 1 minus 1 by n plus 1. Now you apply the limit. Then you have 1 minus 1 by infinity. 1 by infinity is 0. So 1 minus 0 is 1. Ninth sum. An important problem in fishery science is to estimate the number of fish presently spawning in streams and use this information to predict the number of mature fish or recruits that will return to the rivers during the reproductive period. If S is the number of spawners and R the number of recruits, Beaverton-Holt spawner recruit function is R of S is equal to S divided by alpha S plus beta divided by beta, where alpha and beta are positive constants. Show that the function predicts approximately constant recruitment when the number of spawners is sufficiently large. So here R of S is equal to S by alpha S plus in beta. Now you have to apply the limit. Apply the limit on both sides. So you have limit S tends to infinity R of S is equal to limit S tends to infinity S by alpha S plus beta. Limit S tends to infinity S divided by, in the denominator S you take outside, so you have S into alpha plus beta by S. S cancel. Then you apply the limit. So you have 1 divided by alpha plus beta by infinity is 0. So 1 by alpha. Exercise 9.4. Evaluate the following limits. First sum. Limit x tends to infinity 1 plus 1 by x whole power 7x. Limit x tends to infinity 1 plus 1 by x whole power 7x. So this can be written as limit x tends to infinity 1 plus 1 by x whole power 7. Which is equal to, we know that limit x tends to infinity 1 plus 1 by x whole power x is e. So this can be written as e power 7. Second sum. Limit x tends to 0 1 plus x whole power 1 by 3x. Limit x tends to 0 1 plus x whole power 1 by 3x is equal to limit x tends to 0. So this can be written as 1 plus x whole power 1 by x whole power 1 by 3. So which is equal to, so its a formula is e. So e power 1 by 3. Third sum. Limit x tends to infinity 1 plus k by x whole power m by x. Limit x tends to infinity 1 plus k by x whole power m by x is equal to limit x tends to infinity. So this can be written as 1 plus k by x whole power 1 by x whole power m, which is equal to, now you have to substitute x is equal to infinity. So then you have 1 plus k by infinity. K by infinity is 0. So 1 plus 0 whole power, here 1 by infinity. 1 by infinity is 0 whole power m. So 1 plus 0 is 1. 1 power 0, any number power 0 is 1. So 1 power m is 1. The sum. Limit x tends to infinity 1 plus 3 by x whole power x plus 2. Limit x tends to infinity 1 plus 3 by x whole power x plus 2 is equal to limit x tends to infinity. So this can be written as 1 plus 3 by x whole power x into 1 plus 3 by x whole square, which is equal to, now this is of the form limit x tends to infinity 1 plus k by x whole power x. Its a formula is e power k. Here k is equal to 3. So this can be written as e power 3. Here you have to substitute x is equal to infinity. If you substitute, you will get 1 plus 3 by infinity. 3 by infinity is 0. So 1 plus 0 is 1. 1 square. E power 3 into 1 square. 1 square is 1 equal to e power 3. Sixth sum. Limit x tends to 0. Sine cube x by 2 divided by x cube. Limit x tends to 0. Sine cube x by 2 divided by x cube, which is equal to limit x tends to 0. Sine cube x by 2 divided by x cube multiply the denominator, multiply the numerator and denominator by 8, which is equal to, now 1 by 8 is called 1 by 8, you take outside, 1 by 8 into limit extends to 0. So remaining you have sine cube x by 2 divided by x cube by 8. So this can be written as sine x by 2 divided by x by 2 whole cube, which is equal to 1 by 8. We know that limit theta tends to 0, sine theta by theta is 1, so this becomes 1. So 1 into 1 by 8, 1 by 8. Seventh sum, limit extends to 0, sine alpha x by sine beta x. Limit extends to 0, sine alpha x by sine beta x. Here in the numerator you have to multiply by alpha x. In the numerator you have to multiply the numerator and denominator by alpha x. Similarly, and in the denominator you have to multiply the numerator and denominator by beta x. Now x cancel, alpha by beta, you have to apply the limit in the numerator and denominator also. So this becomes limit x tends to 0 means alpha x also tends to 0, sine alpha x divided by alpha x divided by limit beta x tends to 0, sine beta x by beta x. Now we know that limit theta tends to 0, sine theta by theta is 1. Here also 1. So remaining you have alpha by beta. Ninth sum, limit alpha tends to 0, sine alpha power n divided by sine alpha whole power m. Limit alpha tends to 0, sine alpha power n. Now you have to multiply the numerator and denominator by alpha power n. In the numerator you have to multiply the numerator and denominator by alpha power n divided by sine alpha. Similarly, here also in the denominator you have to multiply the numerator and denominator by alpha whole power m, which is equal to limit alpha tends to 0, sine alpha power n divided by alpha power n into alpha power n divided by, so the denominator can be written as sine alpha by alpha whole power m into alpha power m. Now its value is 1. Remaining you have alpha power n divided by alpha power m. So this can be written as alpha power n minus m. Limit alpha tends to 0, sine alpha power n divided by sine alpha whole power m is equal to alpha power n minus m, which is equal to 1 if m is equal to n. If m is equal to n means its value is 1. Equal to 0 if m greater than n. Then f of alpha tends to infinity as alpha tends to 0, m less than n. 10th sum, limit extends to 0, sine a plus x minus sine a minus x divided by x. Limit extends to 0, sine a plus x minus sine a minus x divided by x. Now numerator is in the form of sine c minus sine d. Sine c minus sine d. We know that sine c minus sine d is 2 cos c plus d by 2 into sine c minus d by 2. So this can be written as 2 cos a plus a minus x divided by 2 into sine a plus x minus a plus x divided by 2 divided by x. Here plus x minus x cancel. Similarly here minus a plus a cancel. Remaining you have limit extends to 0 to cos, here 2a by 2 is a. Similarly here sine 2x by 2. Sine 2x by 2 is sine x divided by x. Then so this can be written as 2 cos a into limit extends to 0 sine x by x. So its value is 1. So this becomes 2 cos a.